Hey everyone, so this is 5A, the motor basics. So I've hooked up the motor circuit from the book, and now once you've compiled and entered the code in here, you open the serial monitor and you put in a code between 0 and 255. However, when I do that, my motor only runs briefly. So I do have some troubleshooting to go through. So I've looked online and it's either could be my switch or A7. So I am going to have to sort of figure out, or there's something wrong with the driver, which I really hoped. But I mean, it did run. So I'm hoping it's just a faulty wire. But anyway, that's where I am. And we'll come back with some resolution, I hope. Hey everybody. So the problem I was saying before was that the motor only spins for a second. I thought that was a wiring or a switch or something, but when I watched the SparkFun video, the instructor on the video does say that it only spins for a second. So but that's not clear in the code. You enter it and then it just should, if the switch is on, it should just go. But anyway, he said, yeah, it just goes for a second and then it stops. So I guess I've hooked it up correctly. I'm going to move on because it's doing what it does in the video. And that's it. So yeah, unclear. If anybody knows why in the comments, that would be great. Otherwise, I'm just going to move on to the next challenges, which were spinning it in the opposite direction and replacing the button with a, or replacing the switch with a button and replacing the switch with a sensor. So let's just carry on and just accept that it just goes for 1 second for whatever reason. All right, so this is the first challenge, which was make the switch reverse the direction of the motor. So just put the tire on just to sort of visualize it. So if I go onto the motor basics sketch, put in full power, you can see that it moved towards the circuit there. And then if I flick the switch down and I enter 255 again, we're moving away. So kind of wanted it to be less violent, but that pretty much does it. So what I did was just times the motor speed by -1. So just in that if else statement, so it said if else 0 in there, instead of 0, just the variable motor speed times -1, and that reverse whatever speed you enter into the serial monitor. So there we go. So that's the first challenge there. All right, so this is do the button. So I've added a button right here, and I'll put it in the code, but I've added a serial printout for the button state. So when I press it down, it should say button state 1, which it does. And then if I add 255, and I'm not going to touch it, nothing happens. And then I'm only allowed like a second. So if I press 255 again, and I hold down the button, there we go. So that's the button. It's just on either side of the pin diagonally, like we learned before, and that'll send the signal that the button is down and the connection is done. And yeah, super simple. So we're going to move on to the next one, which is the sensor. All right. So this is circuit 5. This is the last challenge here, which was the use a different sensor to turn the motor on and off. So I've used the photoresistor sensor to activate the motor, and I found the code off the Arduino forum there. And so if I use the flash on the phone here, hooray, light on, motor on, light off, motor off. Super simple stuff. So I will put that in my resources and anybody else can take a look. And we'll move on to Circuit 5B, the remote control robot. All right, so here is the car in Circuit 5B. And I had a little trouble there. There are these tiny nodes on the, they look like just little bumps on the sides of the motors. So they're supposed to be facing the same direction, left or right, when you set up the motor. So like they kind of get placed like that underneath the carriage. So I guess they're placed left. So I didn't quite pick that up. So my wheels were spinning in opposite directions at first. But that was a quick fix. And now if the commands for this sketch are direction and then distance. So the example it says is like forward 50, and you press enter. There we go. So I do find I do have to hold, it says remote control car, but it's obviously not remote. We would need some other sort of LoRa component or on the side there to get full Wi-Fi remote. But anyway, I do get some drag off of the USB. So if I hold it up, it does go in a straight line. Otherwise, it turns because the weight. But it's super cool. And yeah, it's really fun. So the next, there's only a few challenges in this one, just a couple. Well, they're both pretty much the same. It's just like put some extra commands. So I'm going to go see on the Arduino forum what people have done. All right, so I found sort of a fun one. It's not related to this particular circuit, but it was a dance robot on Arduino. It was like a 3D printed dance robot. Anyway, it just gave me a good idea, and it's the execution is really easy because of the way the sketch is set up with all the right and left motors and their variables sort of right in there, and then you can make just apply it to like in the if else statements for the key directions. So if I press D for dance and do like 100, we get a little dance, which I thought was fun. So I think I'm just going to move on to the last one, which was the obstacle avoidance. This is a lot of commands for a little dance that was, maybe like a second long. So anyway, let's get to it. So this is the default sketch for the autonomous robot, and I set it up in my mudroom with a few shoes and boots in the way, and sort of let her rip around the floor here, and it had a lot of trouble sort of navigating around things. I think that wasn't given a whole lot of range turning and getting around things, but it is achieving what it's behaving the way the sketch says it would. So all in all, it was very good, and my cat had a lot of things to say about it. So all in all, fun project. And then the next one is to improve upon the behavior of the robot. All right, so this is the improved performance of the robot. I used three things from some forums about obstacle avoidance, which were random turn direction, spin until clear, and pause and then turn. And all of these combine increase the obstacle avoidance performance of the robot, and it is, as you can see, doing a much better job of scurrying around the mudroom with all the shoes and obstacles. However, it still goes after my cat. Just wanted to have a little reflections at the end here that this autonomous robot was a super fun final project for the SparkFun Inventors Kit. And now I'll be moving on to my final project, which is the self-balancing robot.